base, this is the area of the base, yeah? Why is it saying plus n lots of triangles? I think you're reading too much into it. It's simply that every side of the polygon has a triangle that then comes up to make a point and makes it a pyramid, yeah? Does that make sense? How do you find the area of a triangle? So this is basically it. One lesson thing, not going to be too much. We'll just go through how do you find the area of the triangle is probably the important thing. You will notice I've given. Why do you think I've given you this? Yeah, because people spend 35 minutes trying to draw their pyramid and not worry about what the actual question is. Right? So what we'll do is first of all we'll start with this question, 5 by 5 by 5. We'll put that onto the diagram that I've given you, and we'll work out what the answer is, and then we'll look at, well, what do we do if we don't even need to worry about the different sizes yet, just doing a square-based pyramid at this stage. Right, easy enough, that's the plan. Right. So what is it, 5? The height is 5 and 5 and 5. We've got a bit of vocabulary that we need to know, but let's put this in. So the height, okay, the height equals 5 joules per meters, okay, and the base equals 5 by 5. That means 5 by 5. So if we're going to work out the surface area, right, so I want to know the surface area of the pyramid, well, you wrote down the formula, which is the surface area is the area of the base plus the area of the triangles, and it's how many of them we've got. So we've got n lots of that. That's the formula we're going to use. So in this case, area of the base is just 5 times 5, which equals 25 square meters. So with a square-based pyramid, not a problem. Rectangular-based pyramids, not really working on those yet, but not a problem. Some of you might be asking, what if it's a pentagonal-based pyramid? Or how do I work out the area of a pentagon? Do you remember how to work out the area of a regular pentagon? No? Maybe that's something we need to recap. Say again? Yeah, cut it into triangles. Exactly. Right. What we do now want to know is we've got to work out the area of the triangles, because imagine if we flatten this out, what's it going to look like? Up? The whole shape. Yeah, star. So we've got the square in the middle, and then if we flatten it, it's going to have a triangle, another triangle, another triangle, and another triangle. Okay. So what we're doing is we are going to work out what one of those triangles is, and the area of a triangle, just one triangle, is area equals base times height divided by 2, where this is the height, this is the base. Alright, let's just check. So what is it? The area of that triangle is, base is 5, that's the base. What's the height? It's not 5. Good. Why is it not 5, Steph?
Because that's the height of the whole thing and it's a 3D shape.
So So that's the point here, I think. You realise the height of the pyramid is not the height of the triangle. Okay? So I'm going to add in another line here, and I'm going to put in this line down there. Okay? And this line here, I'm going to give it a name. Does anyone know what that would be already? This will be called the slant height of the pyramid. Makes sense? It's called a slant height. So we actually need to know the slant height of the pyramid before we can work out the heights of those triangles. Alright. So this height here then I want to know is actually the slant. What is that? Any ideas? Just make some space. Any ideas how to know the slant height? Don't know the angles actually. We probably could if we wanted to work them out, but there's an easier way. No, don't move. If I draw down, just to make that clear. Okay. What if I did this? What if I just drawn? Can't be a radius. Yeah, I'm opening. But what if I just drawn another
a triangle?
Not just a triangle, but
you know two sides and then you can
exactly, there you go. So we have just done exactly, yeah. So we've got 5 and we've got 2.5. So the slant height is actually now 5. Draw this triangle. So that was the 2.5, this was the 5, this is the slant height. So how do we do that? We do 5 squared plus 2.5 squared, square root that, and we'll get our slant height. Story of my life, my battery's running low.
I did this the more complicated way.
Say it again?
I did this the more complicated way.
Why would you use enough?
Because he likes
You
to.
haven't told us how to do this one yet.
How did you do it?
I used trig to find one of the angles in the triangle, and then also use it to find the hypotenuse.
Yeah, I get it.
Slant height is 5 point.
Was it 5 point? So the slant height, which shouldn't be h. What did you say? 5.59. Okay. 5.5. Now, just to check, if we put that in there, that line should definitely be longer because it reaches the same point, but it's slanted over. So we've got that as 5.59, which is then the area of, sorry, the height of this triangle. So we've got 5.59, and then let's do that divided by 2. And of course, all of that needs to be multiplied by 4, because I've got 4 triangles. Yeah? 4 lots of them. So what's the area of the triangles? So n area triangle. If you work it out, what do you get? 55.9? Can anyone confirm?
You actually calculated it.
Yeah, that's what I got.
Yeah. So what's the total surface area then? So total surface area equals the 25 square meters plus the 55.9 square meters. So we've got 80.9 square meters. Okay. So that's your surface area of pyramid. So the only real probably different thing is this slant height that's called, that's what you're going to have to use. Do you all recognise how these questions can be extended or changed in any way? What's going to happen? Yeah. Height of the base.
Right, the length of the base.
Could ask you to find, yeah, the dimensions of the base if it's a square.
Could ask, like, it could give you the perimeter of the base and ask you one height.
Yeah, could ask you for the height of the pyramid. Could ask you for the slant height of the pyramid.
Yeah, why do I get the feeling like a criterion D question for this unit would have something to do with the pyramids in Egypt?
Well, I don't know. It's a difficult one actually because you've got to remember criterion D is specifically about, you've got to say measuring to certain accuracies and does your answer make sense, and we've got to have that for criterion D. Quite often people think it's criterion D just because we do skills and knowledge but in a real world sense, but that's not criterion D, that's still criterion A. So if I said to you work out the surface area of the pyramids, one thing, but really then it'd be on, well, is that actually the surface area of an Egyptian pyramid? Does your answer make sense? And you'd be like, no, because actually it's made out of blocks, cuboids, there's lots of steps in it, you know. So this is not an approach, that's how you could change that, I guess. Right. Okay, so over to you. You're given the height. This one, look, you're given the slant height. So that's why I didn't use that one. All right. But you've got question 1. Here, look. What's the difference in question 3?
It's
Okay.
a rectangle.
So you can't just do 4 lots of the triangle. All right. This one actually doesn't go with this, does it? Why? What is a rectangle not?
You need another, you need like, and, like it would have to be S equals A of the base plus.
Well, you couldn't generalize because it's not n-sided polygon. Yeah, a rectangle is not an n-sided regular polygon. It's not a regular polygon, is it? So, yeah. All right, so you got that. You've got this one. Problem solving, tetrahedron. Do you know what a tetrahedron is?
Something to do with 4, isn't it?
3D solid with all 4 faces, equilateral triangles. All right, so a tetrahedron is actually 4 triangles, like some people use as dice. All right, so I think before we move on to cones, next time we're going to make some cones. That'll be fun. A bit of cutting and sticking and, you know, that kind of stuff. But today, try and get through some of these. I've got problems, so it shouldn't be too much. Let me know.